So I'm very excited, as always, to introduce our next presenter. Chaoyi Li is with Booster Robotics, which is building a very exciting new platform aimed at helping developers bring embodied intelligence to the real world. So please give him a warm round of applause and enjoy the presentation. Thank you.
Okay, thank you. Hi everyone, I'm Chaoyi from Booster Robotics, and super glad to be here. So at Booster Robotics, we are actually building humanoids. Right now, we actually focus on building humanoids for developers. The reason of this is we believe that in order to actually bring humanoids everywhere, it is essential to build the ecosystem. So a quick introduction about Booster. Seems not working. Okay, so a quick introduction about Booster. Booster, we are still a very young company. We are founded around 2 years ago, and through a bunch of enthusiasts of robotics and software engineers. And within 1 year, we actually finished our first product, and we launched the product officially in IROS in 2024, October. And at IROS, we sold over 18 units. And over the past year, we have started mass production, and we have supported over 200 customers globally, of which 70 customers are of top research institutes, tech companies, and of which they are actually building an ecosystem over it. So today I want to share a little bit more about our vision. So our vision is actually very simple. We want to make humanoids, robots, just like personal computers, to be simple, reliable, and practical. I guess a lot of people might ask, why like personal computer? Why don't we build something like more like smartphones or more popular, just like how people are doing for electric cars? But the reason actually lies right over here in Computer History Museum. So if we see the pictures down beneath, we can see in the 1970s, Apple II was actually a mystery box in a bunch of people who are actually using it as a toy, as a tool to actually do some kind of research. And then when it went out to the 80s and 90s, we see IBM, we see ThinkPad bringing personal computers and laptops to workspaces. And there we can see professionals using them. And until the 21st century, we have the iMac at home. And then we use the iMac as for entertainment and for creativity. The biggest revolution was actually when Steve Jobs pulled out the iPhone from his pocket. And that was a new device which connected us from the world. It becomes something that we use services for. It becomes something that we literally connect with the society. So if we see this, we actually find one common thing. So at the very beginning, everything actually comes from the computer. All other devices, laptops, smartphones, they are just an iteration of the personal computer. So today we actually see the similar things of a humanoid. So we believe humanoid shouldn't be an isolated, the next platform shouldn't be an isolated platform, robotic arm, for example, in the industrial settings. It shouldn't be a specific robot that works in one scenario. It should be something that people can actually build similar things onto as well. So then there comes to the next question, how are we going to get there? I think that we actually can see this in our own lives. So for human, we actually start from a baby. We start from start crawling when we get born. And then we start exploring the limitations of our own bodies. We start trying to walk, start run, start jump. And eventually, we start to think. We start to create, and we start to finish complex tasks. I think this is how robotics also evolved. If we look back for the last decade, what people are doing on humanoids is giving them more motion capabilities, getting done the locomotion, getting done whole body control, giving robots capabilities to perform dances, martial arts, and different kind of things. And for the next decade, what we see is how should we evolve the cognitive part of humanoids. That is how humanoids see, think, and of course act around the world. So then it comes with one question. For the next 10 years, could this be achieved by one company? one company actually achieve all these capabilities? Our answer is really straightforward, no. So if we look back at the computer era, so we can actually see Microsoft's not making all the games. Adobe is not making other professional tools. IBM is not making all the systems that we are actually using. So it's all actually built by a whole ecosystem. That's exactly what we see for robotics. So transferring from the information era to AI era, we see the similar thing. So we see, first of all, we need a robust platform which everyone can use, similar to the computers, the phones that we use. We need an operating system that actually runs on robots so that people don't have to worry about the low-level middlewares and hardware, middlewares. We need to develop tools which actually are easy to use. Because previously, when we build on robots, it's really hard to actually integrate with the open source tools. So that's something that we see lies a big chance. But we also understand that if humanoid robots remains something super expensive and only a game for a few people, we can't really expect humanoid to be there. We can't really expect the arrival of embodied era to come into our daily lives. So that's why we also brought the Booster K1 with us this time. So the Booster K1 is actually an introductory platform that we have for people who are actually interested in robotics. So we are trying to make it really affordable. So this product actually starts from only $6,000 US. It's one of the most affordable humanoid products that's actually in the market. So what does the K1 do? So we can see, okay, from the very beginning, we can see robots actually doing soccer. And this is actually used by a lot of robotic teams. They're doing multi-agent control. Of course, for entertainment, robots are used for motion capabilities. They can do dances like the MJ dance. And it's actually right over there at the booth. So if you guys want to see it in person, it's always OK to see it. It can be a companionship for children. So we can actually see robots actually running around autonomously. There should be sound. Could you see what's wrong with it? OK, so this is an example of a humanoid at home. It's actually being a tutor teaching his children how to actually speak different languages.
The video. Thank you.
OK, we are actually seeing a lot of different capabilities coming out. And we believe that is actually the way which we can have humanoid into the market. We can have different people working on different capabilities.
No worries.
That is the future. So the K1 is really reliable, really small. So first of all, we because K1 is still for education, for research, for developers, we're trying to make it really developer-friendly and really robust. So we did a lot of durability tests to ensure that, OK, when a robot is used for continuous hours, for example, 30 hours continuously, nothing bad happens to the robot. The robot runs in different kinds of scenarios, in the wild without breaking. And second of all, we are trying to make the robot as small as possible. Because over the last year, when we talked to a lot of developers, we realized that small itself is the productivity. If you have a small robot that you can actually try new things anytime, then you can actually build things and integrate things faster. And of course, small itself also means that you can carry around, do different kind of demos around the world. So you can simply put it into your suitcase and carry around with you to different places. And of course, in order to actually have more people into this robotic ecosystem, we're also providing education solutions, competition solutions. So when students have them in education, they can learn how to program on robots, and then they can compete in different kind of competition. For example, there are over 50 universities which are using the Booster to compete in one of the most famous robotic competition, which is called RoboCup. And what they do is they use robots for playing soccer. So the robots there, they play soccer autonomously. They learn how to percept. They learn how to navigate. They learn how to do different kind of motions. But we understand also, as I mentioned, the platform itself, it shouldn't be just a hardware. I want to quote something that Steve Jobs, Bill Gates actually mentioned before. So he mentioned that as personal computers become affordable and reach everyone's home, then the demand for high quality software will rise. We see that same thing in hardware, like human robots. When human robots, they become affordable, the demand for capabilities of humanoids will also rise. So we have seen on the videos, there's actually different kind of capabilities like running, dancing, playing soccer, like being a tutor. But there's also, we see the potential of people building more interesting things on it. I know like a lot of people would ask, okay, aren't those tasks too simple? Like, shouldn't we do something that is way more sophisticated? We already see robots in factories doing like screwdriving, right? Shouldn't we do that? I think this actually lies in the imagination of the developers that we are actually working with. So what we seek is that we can, everyone that's in this ecosystem could actually create their own agents. So the difference between like agents should be that it should be something active that could be deployed on a humanoid and then actively talk and join the ecosystem that we are in today. So even if we look back around many years ago, if we see the Microsoft Word at the 1984, it's way more simple than the simplest note application that we use on the phone right now. So everything starts from the really simple things, and we believe that together we can actually bring like a humanoid to the next stage. So this is actually a picture of a high school students that were actually competing in one of the robotic competitions. So previously, when even 2 years ago, we see most of the robots were actually only used in research labs by PhD students. Our idea is to really bring down the barrier so that one day, like even high school students, they can go up to the stage and say, okay, we can actually make our own agents. We can actually build our own applications, and we can compete with the most advanced research labs that is in this area. So I want to emphasize once again our vision, and I really hope to have more people join the journey with us to actually bring humanoids into at-home scenarios, into industrial settings, into the society. So we want to make humanoids robots like personal computers, simple, reliable, and of course practical. Okay, thank you. And of course, more time for questions.
Are there any questions from the audience? It's so hard to see. Any questions? I have a question. What are the skills that you want someone to have when they buy this and want to start developing for it? What is the sort of barrier to entry in terms of skills that you expect is a reasonable one?
Yeah. So currently, what we see is essential. There's only one thing. It's coding skills. So if you have the coding skills, you can actually get the robots and start doing all the programming. But what we seek to see is that when there's more agents, you don't have to have the coding skills anymore. Because today, if we use computers, we don't have to have a coding skill to actually use the computer. So doing something more natural is something that we see in the future with human robot.
So even thinking about, to use the worst word for it, vibe coding, someone like myself who's not very experienced with coding, using something like Claude or ChatGPT to help use natural language to write programs for the robot.
Yes, vibe coding would be something that definitely would be doable. I'm actually thinking about something more natural, like just natural languages. That is something that we also see in the future as well.
Awesome. Any other questions? There we are.
Hey, Chaoyi. You met yesterday at the panel. So you kind of know my question. Did you do any user studies on the face? Because I mean, we have seen studies that show that kids respond better to human faces than robot faces. In general, I mean, special needs is a different category. But I'm just curious if you did that.
Okay, so yes, the question would be yes. We're actually doing a lot of iterations and a lot of experiments on the head of the robot as well. So currently, if you see the Booster K1s, like pure cameras, pure microphones, speakers on the head. But we understand that human interaction is super important. So in that case, there should be different ways which humanoid could interact with people apart from just talking and like doing gestures. So the first thing that we are actually testing and trying is having more like screens as one of the first solutions. So that's the first thing that we are doing. The second thing that we are trying is actually having human-like heads on the robots. So currently we don't develop our own heads yet for like human-like heads, but we actually have a lot of customers which are building heads. So heads itself is a really complicated thing. They have to have a lot of motors to make really human-like expressions. So that is something that we are exploring with also our partners as well.
Okay, thanks.
Any other questions? No one? Oh, here we are. Oh.
Hi. I understand the use of software apps and things like that, but what about hardware? Can you use tools with it or any applications like that?
Yes. So the K1 is actually the introductory platform for the Booster platforms. We actually also have the T-Series. And now we actually have people who are working on the T-Series with the local manipulation, whole body manipulation. And in that case, they're actually using human tools. So for example, with the T1 with the dexterous hands, they're actually doing screw driving with the whole like teleoperation and training the skills for robots to do things like that as well.
I saw one more question over here.
Yeah, when you talk about the operating system, do you go down to the kernel level, or are you building frameworks and languages that make sense there?
Yeah, so currently we still rely on the Ubuntu system for our robots, but we are actually building things on top of it first. So really, we start with the development tools. We start with building a tool for developers which they can use on Windows and on Mac OS without actually installing really different operating system on their computers so that they can develop things faster. And then integrating with the existing simulation environments to get the coding done in that one platform is the thing that we are doing right now. And then the second step will be moving on to a system which people can build different agents on easier.
Is it ROS right now?
Right now, the robot supports both ROS and non-ROS. So ROS is a part which it supports, but you can also use the DDS to connect directly with the APIs.
Cool, thank you.
I think we have time for one or two more questions.
I guess I was just curious if it looks like it's a 4-degree of freedom arm right now. Are you planning to add an option?
Yes.
For 7-degree freedom arm?
Okay, so for the K1, probably not. The reason of this is that K1 is actually a small platform, but we also have the T1, which is also there. And for the T-Series now, there's actually 7 degrees of freedom arms already. So all T-Series, they are equipped with 7 degrees of freedom arms, and they are equipped with dexterous hands and grippers. So that would be an option, because we believe that height would be good enough to actually reach human environments.
Great. And you have these robots on display out in the exhibit hall,
Yes,
is that correct?
for sure.
Awesome. Well, please make sure you go and check them out. Please also give them a round of applause. Really appreciate your time, and looking forward to seeing more from you guys.
Thank you.
Thank you. Thank you. I'll take that. Yes, sir. So our